Welcome to math class. We are continuing on in the Math Makes Sense 9 textbook. We are starting on Unit 5.2. We are skipping over 5.1, mostly because that whole unit is all about basically just how to use algebra tiles. And we are going to stay away from using algebra tiles during this class, mostly just because learning an extra skill on top of the math just adds too much complication. So we're just going to stick with the basic polynomial skills and understanding why and how we need to use these. So we're going to start off with the example on page 219. So at the bottom of the page there, they have an equation, 4n squared minus 1 minus 3n plus 3, or sorry, minus 3. So minus 3 plus 5n minus 2n squared. So the first skill we want to learn is we want to be able to recognize like and unlike terms. So what I'm looking for first off is any numbers that don't have any variables attached whatsoever. So I have -1 because you include whatever operation is in front, and -3 are going to be my two numbers there. The next thing I'm looking for is any terms that have just a single variable attached. So I actually have -3n and positive 5n can be grouped together. And then the last one is any any terms that have variables with similar exponents. So I have 4n squared and 2n squared. So what I'm going to do is actually rewrite this equation with all of my like terms grouped together. So I have 4n squared plus 2n squared minus 3n plus 5n minus 1 minus 3. Within there, now I'm going to combine each of my like terms and simplify it as best I possibly can. So 4n squared plus 2n squared, remember that whenever we have a variable with an exponent attached, I'm not going to be messing with it. I'm not going to be changing my variables or changing my exponents. All I'm actually dealing with is the coefficient in front. So I have 4 plus 2n squared, so I actually have 6n squareds here. I have -3n's, positive 5n's, so I'm left with positive 2n. And then here I have -1 minus 3, so I'm left with -4. So my, oh, did I forget something here? Oh, this is actually, yeah, I wasn't paying attention. This is not a positive. This is a negative. That's what I get for trying to read my own messy writing, which means that 6n squared actually becomes 2n squared because I have 4n squared minus 2n squared. So 2n squared plus 2n minus 4 is our final answer for that example question. This is the best method, or the method that I recommend for solving all of these questions. Group your like terms together, rewrite the whole equation with all of your like terms grouped together, and then you can break it down and bust each like term group, for lack of a better word, down into an easily usable term. So that's how we're going to do that. So let's take a look at a couple more examples. So flip the page over, and I have an example on the top of page 220. Okay. So let me extend this so that my page isn't bumping all the time. So page 220, the example they give us is a relatively long one. I have 14x squared minus 11 plus 30x plus 3 plus 15x minus 25x squared. So first step is to group like terms. I always like starting with my standalone numbers. So I've got -11 and +3 here. Next up, I'm going to look for terms with only one variable. So I have positive 30x, positive 15x, and then I'm looking for any terms that have variables with exponents. So I actually have 14x squared and negative 25x squared. So I'm going to go ahead and rewrite this entire equation, but with my terms like grouped together. So I have 14x squared minus 25x squared plus 30x plus 15x minus 11 plus 3. Now I've got my terms basically in little groups here. So now I'm going to simplify them down. 14x minus 25x squared, 14x squared minus 25x squared winds up becoming negative 11x squared. 30x plus 15x is a positive 45x. Negative 11 plus 3 gives us a negative 8. So negative 11x squared plus 45x minus 8 is our final simplified equation for that one. But, and this is actually one of the few examples of how we can use polynomials in real life, what happens if we have a graphic representation, so to speak? So I'm actually going to draw this sort of relatively easy way. All right, so in there they give us an example of a rectangle with 3 boxes in it. 1, 2. And what they say is this side length is x, this side length is x, this side length is x, and this side length is x. What they want you to do is write a perimeter equals, and then they want an equation. All right. Well, I know from our last unit that perimeter is found by adding up all of the sides and adding them together. So my question becomes, what is the length of my top side? Well, it is x plus x plus x, or 3x. So that means that my top edge is 3x plus my side edge, x, plus my bottom edge, which is going to be the same as the top one, 3x, and my last edge over here is going to be the same as this one over here, so I get plus x. So I have 3x plus 1x plus 3x plus 1x, so I actually get 4x plus 4x, which equals 8x. Okay, I can even put a p in there. P equals 8x. And that's how I solve, or sorry, that's how I write an equation that represents the perimeter of a figure where I don't actually know any of the measurements, but I'm still able to come up with an equation. There's going to be a couple questions like that on the assignment, so keep your eyes out for those. And then the very last example is on page 221, and this is an example of what to do when we have multiple variables. And I don't just mean exponents, when I've got more than one variable involved in my sentence. So the example they give us here is 4xy minus y squared minus 3x squared plus 2xy minus x minus 3y squared. So same thing I've got to do here. I have to start grouping like terms. I always like to start with what I call the naked numbers or empty numbers with no variables. I don't have any in this particular equation. So what I'm looking for is empty numbers that have just a single variable by themselves. So the first one I have here is negative x. And what you can even think about this in order to make it easier for yourself is this is actually negative 1x. So what I'm looking for is any other term in my equation that has the x variable attached, but there aren't any. This is the only x variable, so this is the only term that is like this one. Or another way of saying that, there's no other like terms in this equation. So the next thing I'm going to look for then is I'm going to be looking for equations that have, or sorry, terms that have variables and exponents. Right? But I actually have a few different ones to deal with here. Now, it should go without saying, but x squared is not going to be the same as y squared. So I can't treat these as if they were like terms. I have to treat them completely different. And I just realized how much of a mess I made. That one's y squared. That one's 3x squared. So, okay. So what that means is I'm going to be grouping together all my y squareds and my x squareds. X squared, that looks like it's the only one in the statement. Oh, I lost my page in my book here. Okay. So negative 3x squared is, again, the only one by itself. The last type of term I'm looking for is any of them that have two variables attached. So they have the same variable. So the same way that y squared is not the same as x squared, xy is not the same as x or x squared or y squared. xy is its own term. So I actually have two of those. Following my same steps, I'm going to group them. I'm going to rewrite the whole equation and group them together. So I have 4xy plus 2xy minus y squared minus 3y squared. Oh, my book keeps flipping pages on me here. Minus 3x squared minus x. So I've got my terms grouped together. These two are basically on their own. So I'm going to shorten this down. So I have 4xy's plus 2xy's gives me 6xy. I have negative y squared minus 3y squared. Remember, negative 1y squared is another way to think of that. So I actually have negative 4y squareds here minus 3x squareds minus x. So my final equation is 6xy minus 4y squared minus 3x squared minus x. That is how we group like terms and unlike terms. I will see you in class.